So I'll be solving the second exercise from week 4 list of exercises. So we're working with this dataset ICU original cvs.csv that contains data on patients admitted to ICU. And in the second question, we want to examine the linear relationship or the potential linear relationship between systolic blood pressure and probability of not surviving the ICU in the logic scale. We'll do this by plotting the systolic versus probability of dying with the lowest curve and also the predictive value from a logistic regression with linear effect for systolic. Okay, so let's do this. So I'm going to import the data set. Again, this is the ICU-origin csv.csv. I'm going to run the import command. And now I want to produce the plot. And I'll start by producing a scatter plot. A scatter plot for STA, which is the discharge status, versus the systolic. Okay, so I'm just going to do accept and submit, and this will produce a scatter plot. And of course, it's not very interesting because the discharge is either 0 or 1, so we have the typical scatter plot for a binary outcome versus a continuous one. Okay, but I can fit a lowest line that will be fitting here the probability of being discharged dead. So I'm going to add another plot on top of this one. That's why I didn't close the graphic command. If you close it, you can still go back to a graph, and this should still be the previous command there. So the plot 1, and I'm going to create another one, and this one is going to be an advanced plot, a lowest line with the same covariates. So STA is the Y variable and C's is your X variable. Okay, accept, and again I'm going to do submit, so this is not closed. And here is the smooth line approximating the relationship between systolic and probability of death. Okay, so you see here towards the middle, it seems to be the effect seems to be more or less linear. Not linear in the sense of a straight line, because we're plotting this for the probability of dying. So this would be linear in the logic scale. So in the logarithm of probability under 1 minus probability. But so what we want to see here is sort of an S type of curve. Clearly here towards the end, this curve goes up, so it doesn't really fit the usual logistic model. But again, this is only based on one observation, so I'll not be very worried here towards the end. Okay, so this is hard to see if a linear effect for systolic will fit well. So what we'll do is actually, I'm going to put this here in the side. I'm going to run the logistic regression, so statistic binary outcome logistic regression for the variable STA using the independent variable systolic or covariate systolic. I'll run OK, so I'm fitting a logistic model, and now I'm going to the post estimation commands, and I'm going to store the predictions of the probabilities given by the model. Okay, so I'm going to store this predicted probability of a positive outcome. Well, here the positive outcome is death. It's not positive in the sense of a good outcome, but the probability of being 1. And I'm going to call these STA pred underscore linear model, okay, or sorry, linear effect, LE. I'm going to do okay. So I've created now a variable sta pred underscore LE that should be appearing at the end of the data set. So this gives me the probabilities predicted by the model that I just fitted, probabilities of dying based on systolic given by this model that I fitted. Okay, so I can now bring again the plot menu, and I'm going to add a third plot that is going to be a scatter. Actually, I'm going to do it. Well, let's start with the scatter, and then I'll change it. I'll show you in a second. So here, instead of STA, I'm going to put the predicted STA, and the X variable is going to still be the Cs variable. Okay, so I'm basically plotting the predictions of the model and see if it fits well the lowest line. Accept, and I'm going to do submit. Okay, and here you have the predicted values of the model. Okay, they don't fit very well here at the top, but again, there's less observation, so it's really hard to see, and clearly it doesn't fit well towards the bottom. But in any case, this is part of the S curve that we are fitting with the logistic model, right? It's not a straight line, but it's like this S-shaped curve of the logit. And by this comparison, I wonder if that's the best option, the fitting of the model with systolic, sorry, as a linear effect. But we'll investigate this afterwards. I just wanted to, instead of plotting, the predictions with dots, I want to plot a line. Okay, and the reason I didn't do that immediately is that if I change this to a line, because the values of the systolic are not ordered, I'm going to have something quite messy. So you see the lines are connecting the dots in the original order in the data set, which is not the order of the systolic. So before this, I'm going to actually sort this by the data set by systolic, just by writing sort systolic. So I'm sorting the data set by systolic, and now I'm repeating the plot, and here I have the dots connected, so in a nice line. Okay, so this was exercise number 2, and I've also asked you to plot the results in the logic scale. It turns out that it's actually quite a bit complicated, because I have to store the predicted values for the lowest and plot them in the transforms scale. I have the solutions for these in the do file that I've posted, but I'll not do it here in the video.